and it just matters the distance, or
Yes.
I don't really know how to explain it, but
Yes,
that's
I understand. So let me, and what is speed? Can you tell me what is speed?
speed is just exactly how fast they're going along that path.
Yes. So in your car, in the accelerator, I think it's called. So or not the accelerator, is speedometer. So what does it show? Sometimes it shows 30 kilometer per hour, 40 kilometer per hour, depending upon how fast you are driving. But it doesn't involve any direction, correct?
Yeah.
It doesn't involve any information on whether you're driving east or west or south or north. It doesn't involve. It just shows how fast you're moving at that point. Is that correct?
Right.
That is the idea of speed, exactly how fast you're moving at any direction, let's say. But velocity is speed plus the direction. All right, so if I say you're moving at 30 kilometer per hour in east direction, that is your velocity. All right, but if
Uh-huh.
if I just say 30 kilometer per hour, that's the speed, correct?
Yeah.
All right, so and even before that, there are two quantities that you need to know. One is displacement, one is the displacement. So displacement, I'll just write short displacement. Another is total distance. I think you already know this, but still it's good to have a recap. So this is called total distance covered. Okay,
Okay.
so total distance. And can you tell me which one is what?
Um,
So let's
the
let's start from an example. So this is point A, and another point is B here. You see the board, right?
yeah,
Okay. So from A to B, the displacement is a straight line between these 2 points. Is that correct?
yeah,
Okay. And distance travel could be anything like this, something here and here. Is that correct?
yeah. So the displacement is 3 meters, and the total distance is like 43, I think it said.
Yes, yes. So it's basically the total distance is in total how much. What is the length of the path that you cover, and that could be 45 or could be even bigger than that. So it depends upon the road that you are taking. Is that correct? So let's say
Yeah.
from your home, A is your home and B is the library, let's say. So from your home to library, there are 2, 3, 4, 5 different roads. Is that correct? Let's just assume. Then, depending upon which road that you are taking, which path that you are taking, so you'll have different total distance. Is that correct?
Yeah.
But the displacement, which is the straight linear distance between these two, is constant, is fixed, right?
Yes.
So that is the, and now if we say the displacement, we in general associate displacement with a direction. So A to B is this particular direction, A to B, and B to A is this direction. Is that understood?
Yeah.
Okay. So, and velocity is displacement
Over time.
over time. Yes, displacement, I'll just write DISP, and over time. And can you tell me how much is speed? How you define speed?
The speed is total distance over
Over
time.
time, exactly. Okay. So now you understand that since I told you displacement itself has a direction, whether it's from A to B or it's from B to A. So displacement carries an information of the direction. Is that correct?
Yeah.
So velocity should also carry information about the direction. Is that okay?
Yeah.
So do you understand that since displacement already has the information of the directionality, so displacement divided by this time is just a number, 5 second or 10 second or 5 hour, that's just a number, but you have
Yeah,
the
I understand that displacement is a vector, so you have to
displacement is
have.
a vector. So displacement divided by time, which is velocity itself, is a vector. Is that correct?
Yes.
Okay, so we define vector as quantity and over arrow, and the displacement is a vector. So vector divided by scalar gives me a vector. I think you already know this.
Yeah.
Okay. So why don't you tell me the answer for this particular problem that you have here? So 43 meter is the total distance covered. Is that correct?
Yes.
Okay. And 3 meter is the displacement.
Yes.
So what is the velocity?
Velocity equals 0.3 meters per second.
Yes. 3 divided by 10, right?
Yes.
Oh,
And the speed is
40,
4.3.
40, 43 divided by 10, right?
Yeah.
Okay, so
Yeah.
that is the speed, let's say. Speed 40, 43, 43 over 10. So that's the basic idea about this problem. You have to know the difference between velocity and speed. That's all. Okay?
Yes.
Okay. And about the next one says at t equal to 0, a car traveling south at 20.0 meter per second per inches away from a station. Observe. Okay. What is the magnitude of the displacement of the curve with respect to the moving observer? Okay. Can you tell me how we did that?
Yeah. Let me look at it. So it says at t equals 0, a car traveling south at 2 meters per second passes inches away from a stationary observer. What is the magnitude of displacement of the car with respect to the moving observer 10 seconds after or later if she in the meantime walked 15 meters north along the road?
Yes.
Um, no, I don't know how to do that.
Okay. 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 So
I mean, as you're
this
explaining it,
particular
I'll probably.
you
Huh?
you okay. Why don't you tell me whatever that you know? Okay.
Okay, so we know that
And if
time.
it helps, you can draw a diagram as well.
We can what?
You can try to draw a diagram as well, a schematic of the particular problem.
Okay, if you don't mind, let me do that on my paper
Sure,
first.
sure, sure.
So,
Otherwise, I'll do it anyway. So, and you can then check with your diagram that you just drew in your pen and paper.
uh, velocity initial equals 20 meters per second. 607. 10 seconds later. 10 seconds. Changing axis 15 meters north. Okay, so what I have is
Yes,
that. So we have, is this like we have like a before and an after? So for before, time equals 0 and
yes,
velocity initial equals 20 meters per second.
yes.
Um, and then after, we know that time equals 10 seconds and the change in distance equals 15 meters north.
For the observe, for the person who was walking, right?
Yes.
Okay, so here I just try to draw a diagram here. So O is for the observer, the one who was walking, and C is for car. Okay.
Okay.
So this curve moves in this particular direction, and what it says is, let's say the car is moving in south direction, okay, and the walker is moving in the north direction. Okay, so this is the south direction. Let's say, let's just assume. All right.
Yes.
The north should be exactly opposite to that. Is that correct?
Yeah. Uh huh.
So this is the diagram for up to 10 seconds. Let's say up to 10 seconds the car is at here, car is at here, and the observer is at here. All right. You have to understand
Okay.
the direction because the car and the observer, they are walking in the opposite direction, mutually opposite direction. Is that correct?
Yes.
Because the car is traveling in south direction, whereas the observer, the person is walking in the north direction. That's all. Now what
Yes.
happens is, now the displacement is how much? Can you tell me how much is the displacement, net displacement between these two, the person, the observer, and the car? You already know that this is 15 meter, I guess. That is given in the question. 15 meter, right?
Yeah.
Uh, this one.
Yes.
So in
And so
10 seconds, the person actually moves 15 meter, walks 15 meter in the north direction, right?
yeah,
And what we know is the car has a velocity of I guess 10 meter per second. Was it 10 meter per second?
I think it's 20
Okay,
meters.
okay, okay, okay. The number doesn't matter. So let's say 20 meter per second. All right,
Yeah.
and then it moves for it travels for 10. It travels for 20 meter per
So
second and 10
it
seconds. Okay, okay,
traveled
okay.
200 meters.
So in total it moves
It's
200
215.
200 meter in south direction. Is that correct?
Yeah.
So 200 meter in south direction. So what is the displacement between these two in total? Can you tell me?
215 meters.
215, exactly. That's the answer. That's the idea of relative displacement. See, individually the car actually displaced by 200 meters. Is that correct?
Yeah.
In individually, and individually the person he also walks 15 meter. Is that correct?
Yes.
But since they are walking in the opposite direction, they have the distance between them increasing, and that is increased by 200 plus 15. So whatever their individual distances, they just add up. Is that correct?
Yes.
Okay, so that's the idea. Now just try to imagine a different scenario where the person actually walks in the same direction as of the car. All right,
Uh-huh.
then what would happen? What would be the relative distance? Can you tell me?
Well, you would have to subtract 15 from 200,
Yes,
which would be
then it should be
85.
185, right? So
Yeah.
this is the idea of relative distance. Relative distance, relative displacement. It depends upon exactly depends upon the direction of both individual directions. Now what happens is the person could actually walk exactly perpendicular to the car. That could also happen. Like the car is moving in this direction, whereas this particular person is moving in this other direction. That could also happen, right?
Yeah.
So it's like you are moving in this direction and I'm moving in this direction, right?
Yep.
So after some time what would happen is our net displacement would be this one. Is that correct?
Yes.
So then this problem won't be very easy to solve. It won't be just adding or subtracting. Then there will be a bit of algebra and Pythagoras theorem involved in it. But then we can find it out. The
Yeah.
idea is you have to know individual directions in which they are moving. That's all.
Okay.
So you got the point, right?
Uh-huh.
Okay. So now
Yeah.
what what we could do is we'll quickly move on to the next problem, and we'll do the first two of that. After that, we'll again come back. Is that all
Okay.
for you? Otherwise, if I try to solve all the problems here, I won't get any time to look at other problem sets as well.
Yeah, do you think that the problems further down are a little harder and maybe we should go over those, or are they all about the same?
Which one? Which one? Can you tell me again?
I don't know. We were just doing one, two, and three, and usually by the time you get to like number 8 or 9, those are the harder ones, you
Yes,
know? I don't
yes,
know.
yes,
I don't
yes,
know if this is
yes.
the
I understand.
case or not.
So I try to do first one first because it gives me an idea of if you have the even the very prerequisites to go over all the questions or not. Because the point is, if you don't understand the first question itself, then there is no point in solving the eighth question. So do
Right.
you get the point? So first we'll try to solve the first question, and if you can solve that, then we'll move over to fifth or sixth or seventh, depending upon whichever that we want to. All right.
Okay.
But the
So which one do you want to do number three? Which one do you want to do? Is what I'm asking.
problem set, let's say problem set 3, first question.
Okay, let me open it.
Thomas Magnum, that one.
Okay. So problem set number three, first question.
Yes.
Says Thomas Magnum, private investigator, is sitting in his Ferrari with a mass of 1050 kilograms on the side of the road outside Hawaii. He sees a suspect in a murder he has been investigating past him How much net force is exerted on the Ferrari if it reaches a speed of 26.8 meters per second in 6.8 seconds?
Okay, so what did you understand from this one?
Well, I can give you the information, but I don't know how to solve the
No,
problem.
you don't have to solve the problem. That's why I'm here. But you
Okay.
have to tell me at least whatever that you get from here, so that I understand from where I have to start.
Okay, so the mass is 1,050
Yes,
kilograms.
yes.
The speed of the car is 26.8 meters per
No,
second.
no, 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 no. That's wrong. So what happens is initially, I mean that's not wrong, but that's just part of the story. Initially, the car was at rest. Is that correct?
Oh, right, right.
So
So the
he
initial
was just sitting
velocity.
there. So initially, so what we'll have is please take a look at the whiteboard now. So we have two quantities. Let's say ui and uf. U is the velocity. Let's say okay.
Okay, so
Ui
you,
is for initial velocity. Uf is for final velocity. Right?
yeah.
Okay.
So
How much is initial velocity? First, you tell me.
0 meters
Why?
per second.
Because it was at rest. Correct?
Yeah,
And
yeah.
what is the final velocity? Let me just look at the question. Thomas,
26.8 meters per second.
yes, 26.8 meter per second. And what else is given? The mass, right?
Yeah, the mass
Okay,
and then
whatever. Mass is given, but then there's another thing given: the time. How much time is required from accelerating from speed of 0 to 26.8, right?
yeah,
And the time is how much was the time? The time was, I guess,
6.8
six
seconds.
point eight second. All right. So time is 6.8. So from here, if I ask you to find the acceleration, the average acceleration, can you do that for me?
So we would take final minus initial velocity over time.
Yes. And how much should that be?
Let me grab my
No, no,
calculator.
you don't have to grab your calculator. You don't have to give me number. The just the idea.
Oh,
This
I'm sorry. Okay, 26.8
it,
over
it, it,
6.
it it should be uf minus ui over t. Correct?
Yeah.
Okay. And you can even solve the. You can even find the numerical value when discussing. So no problem. See uf minus ui over t. Correct?
Yeah.
All right. And how much is that? That is 26.8 over 6.8. That's all I want to know.
Okay.
26.8 over 8. 6.8. Now, if you know the acceleration, let's say, and then you know the mass, can you tell me the force?
Can I tell you what?
The force acted on the body, on the this particular car, on the object.
Is force equal to mass times acceleration?
Yes, and what is this called? Force equal to mass times acceleration. What is this called? You know,
I
this is a very famous equation, maybe the most famous equation in physics. This is called Newton's second law,
Oh, right.
right? So this says if you have force F, which is equal to mass times the acceleration of the particular object. All right.
Okay.
So you know you have already found the acceleration, correct?
Yeah.
And
So I just went.
you know what is the mass, that is also known. Then you can easily plug in the numbers here and get the value of force. Is it correct?
Yeah.
All right. So that's all is asked in the first part.
Okay.
All right. So the second one is while chasing the murder, Magnum engaging gunfire using his code, which okay. All right. So this one is a bit difficult. So can you tell me how to solve the second one, or can you please read it out?
Yes, so while chasing a murder, Magnum engages in a gunfight. His gun fires a 15-gram bullet at the speed of 250 meters per second. If
Yes.
one bullet enters a wall and comes to rest within 10 centimeters of the surface, what is the average net force on the bullet?
Okay, so what was the average net force? Okay, so they're interested in net force only. So what we'll do is, all right. So we know okay. So why don't you try to form the question first? Afterward, we'll try to solve. So again, you will have to find the force. Is that correct?
Have to find what?
We have to find the force
Oh,
on
yes, net
the
force.
bullet. Okay, so the
So,
net force. So to find force, what we need to find is mass and the acceleration. Is this correct?
yes.
Because force is given as mass times the acceleration. So what we know in this equation, and what do we have to find? Please tell me that.
Well, mass is 15 grams.
So mass
Initial.
is known. Is that correct? Mass is known. So we don't even
Yeah.
bother about that. But acceleration, that is not known. Correct?
Yeah.
And then do you have any idea how to find acceleration? Just like the previous problem.
Yeah. It's 250 meters per second
That
of,
is the initial velocity. Correct?
yeah.
So what you have
That's,
to do is v final minus v final minus, let's say, v initial, which is given. So v initial is known, 250 meter per second, correct?
yes.
Divided by the time. So you have to tell me what is the value of v final and the time.
Is V final 0 because it enters the wall?
Yes. So we know both v final and v initial. That means we know the numerator. But do you know the denominator here? Time? How long it takes to come to rest?
Well, it's not given.
Yes, it's not given. Instead, what is given? Instead of time, what is given?
The distance and the
Yes,
speed.
before the bullet comes to rest, how far it travels? That is, I think, 10 centimeter is given there.
So, is it gonna
So
be?
using that particular
Hold
information,
on, let me figure it out.
yes.
Change in meters over time, so equal speed times time. Um, so we have 1,000 meters divided by time equals 250 meters per second multiplied by time. Time cancels. And then divide by 250 meters per second. So time equals 1,000 meters divided by 250 meters per second.
Uh, could you tell me once again how much it should be? A speed of 250 meter per second. If one bullet enters the wall and comes to rest within 10 centimeter of the surface, okay. What was that? Okay, so how do you do that?
So I came up with time equals one.
So what I'll just write whatever you say, and then we'll see if it is correct or not.
2, 3. Oh, okay. So it's not 1,000 meters. Is it 0.01 meters or 0.001? How do I go from centimeters to meters?
1 centimeter, or let me just write 1 meter is equal to 1,000 centimeter. 1,000, that means
Okay,
10 to the power 3 centimeter.
so it's 0.01 meters
Yes.
divided by 250 meters per second gives you time.
So is that, do you think that should so what is the basic assumption of using that particular formula that you just used? What you use is total distance traveled, which is 1 centimeter, let's say, divided by, not 1, it was 10, I guess, 10 centimeter, and then divided by the velocity, correct?
Yes.
250. But then how could you divide by 250 if 250, this number itself is not constant? This velocity is getting reduced from 250 to 0, correct?
Yeah.
See, within that particular material, a bullet enters a wall. So within that wall, the velocity of the bullet will get reduced, correct?
I didn't understand.
Yes. So please try to look at the question, the second line, that if, if one bullet enters a wall, can you look at it?
Can I tell you what is?
Can you please look at, do you see the question?
Yeah.
Okay, so there is one line where it says, if one bullet enters a wall and comes to rest within 10 centimeter of the surface. Okay.
Yeah.
Okay, so how can a bullet just come to rest if there is no acceleration, there is no retardation of its velocity? You understand me?
Oh, I hold on. I can't really hear you very well.
Okay.
Okay. Okay, what did you say?
Yes, I'll just draw a diagram for that. So when the bullet enters the wall, okay, so let's say this is the bullet is entering the wall, okay,
Mm-hmm.
and it has a velocity of 250 meter per second, whatever that it has something, okay. Now
Yeah.
it enters 10 centimeter into the wall and then comes to rest, correct?
Yes.
That means if it comes to rest, means its velocity is changed, correct?
Yes.
So if its velocity is changed and it's changing over the entire period of traveling inside the wall, because the wall is actually resisting the motion of the bullet. It doesn't let the bullet go easily, correct?
Yes.
That's why the velocity of the bullet is getting reduced eventually to 0. So if you just divide it by 250, the total distance divided by 250, then you will not get the total time. Is that correct? Do you understand this argument, or you want me to go over again?
Um, well, what are you saying? I need to add the 10 centimeters to 250?
No, no, I'm not asking you anything. What I'm saying here is this particular argument that you told me, time equal to whatever the distance divided by total time, that is not correct. That's what I'm trying to make you understand. It is correct, but not correct in this particular case. When is it correct? When the bullet travels at a constant velocity.
Okay, so I
If
need
the
to find
bullet,
average velocity.
you will actually find the 250 is the initial velocity when it starts to enter the wall, and then when it stops at rest, it has a velocity of 0. So that way you can do, you will have average time, but I think we'll use other equation, kinematic equation, s equal to ut plus half ft squared, s equal to ut v equal to, or this one would be even easier to use, u squared minus twice fs. Have you ever seen this particular equation?
Um, I don't know what U stands for.
U is the initial velocity, v is the final velocity, f is the acceleration, s is the distance traveled.
Okay, so yeah, I just write it differently.
Yes, that might have happened, different convention, but they're the same equation. In general, what you say is instead of minus, you will write a plus here. So there are three kinematic equations, and I assumed even before solving this question that you have already studied. Otherwise, I'll teach you them as well.
Yeah, we've studied them. I just don't know it very well.
Okay, so there is one equation v equal to u plus ft. So you may have different convention. U is the initial velocity and v is the final velocity. All right.
Yes.
So, and there is another equation of this one. I'll just write it 2 and I'll write the first one as 1. And I think you have seen both these two equations, so I'm not going over these equations, right?
Yeah.
Okay. So try to understand what we have to find here. We have to find the time. Is that correct?
Yes.
Time taken, so that if I can find the time, let me change the color here. If I can find the time taken for the bullet to come to rest from 250 meter per second, then I can easily find the acceleration and I can find the force. Okay.
Yeah.
Okay. So, or this equation itself, if I use this particular equation, let's say, so what do we know initially to start with? I know the initial velocity is 250. Do I know that?
Yes.
And the final velocity is 0, right?
Yeah.
Final velocity is 0, and the distance traveled by the bullet inside the wall is 10. I know that as well.
Yeah.
So what is it that I don't know?
The acceleration.
Acceleration, yes. And in this case, it is the retardation. I mean the negative acceleration, because the bullet's velocity is getting reduced inside the wall. Is that correct?
Yeah.
I mean, do you understand that the bullet
Yeah,
acceleration?
I do. I do. I'm sorry. Yes, I do.
Okay, okay. Then this positive is replaced by the negative. You understand that?
The
In the particular formula you have, I'm just trying to write over here, v squared equal to u squared minus twice fx. And why is this minus? Because in the formula where we had plus twice fs, f itself, f is the acceleration itself, is negative. Is that correct?
yeah.
Negative means velocity is getting reduced over time,
Okay.
which is happening in when a bullet is trying to penetrate a wall. So
Okay.
after some time, its velocity is reducing, and it eventually becomes 0. Right?
Yes.
So the acceleration, the rate of increase of velocity is actually negative. That means velocity is actually decreasing. Right?
Yeah.
Okay.
Yes.
Okay. So that's why f is negative, and if I put f negative value of f, then simply the formula becomes u squared minus twice fs. Correct?
Yes.
Okay. So we know u, we know v, we know s. S is 10, but 10 is in centimeter. It's not in meter, so you have to convert in meter to put it in the formula, and we can find the acceleration. Correct?
Yes.
Now, once we have the acceleration, we have mass as well given in the question. We can easily find the force. Is that all right for you?
Once we have acceleration, yeah.
Yes. So, what if you just try to look at this particular equation, f equal to mf, this one, all right?
Yeah.
What you have is given in the question is mass, and
Yeah.
you were asked to find the force, and you simply know you have to find the acceleration and multiply acceleration to mass in order to get force. Is that correct?
Yes.
So your next job is to find the acceleration. So to find the acceleration, you exploit the kinematic equations that you have, because the velocity is changing, so there is some acceleration. Now what you notice is velocity is actually reducing, so acceleration is negative. Correct?
Yes.
So acceleration is negative. That means in our formula we put negative acceleration, and that makes the formula u squared minus twice fx, just like this, right?
Yes.
And from here you just put in all the numbers. Final velocity is 0, initial is I think 250, and then the distance traveled inside the wall is 10 centimeter this time. So you have to convert it to meter, divide by 1000 to get the meter value, and then you put in this number, and only quantity that you don't know is the acceleration, correct?
Yes.
You find the acceleration, you just substitute in the this particular formula.
So, algebraically solving it, does acceleration equal 250 squared divided by 0.2 meters?
Yes, that I'll just write it in a moment. So it should be 250 squared, right? Because it's
Yes.
u squared. So what you have is 250 squared divided by 2 divided by 2 divided by 2 multiplied by the value of s. S is 10 over 1000, so 10 over 1000 0.01, 0.01. So this should be the value of the acceleration. Did you get the same thing?
Yeah, I just my decimal point was in the wrong spot. I had point 0.2 instead of 0.02, but
Okay, okay.
okay.
So it should be 0.02, right? Because 10 centimeter. So 10 centimeter divided by 100 is zero point 0.1, divided by 1000 is 0.01. You have 1000. So you just cancel out 10 and 0. So you have 1 over 100. 1 over 100 is equal to 0.01. I think that's correct.
Yes.
Alright. So what you have is 0.01 multiplied to 2 to give you 0.02 in the denominator, and in the numerator you have 250 squared divided by 0.02. Alright.
Yes.
That is the value of acceleration. Okay. And that acceleration will be multiplied to the mass. I wanted to discuss this problem because it is not very trivial to understand which of the 3 or 4 kinematic equations that you should use to just to have an idea of what are the quantities given, and from that what you have to find. You have to choose the kinematic equation. All right.
Mm-hmm.
Now let's just assume, instead of the distance given in the question, the distance 10 centimeter was given, right?
Yeah.
But let's say the final velocity is given. So you already know the initial velocity to be 250 before entering the wall, and let's say final velocity is given. Final velocity is maybe 0, all right?
Okay.
And from there, what you have to find is, let's say v equal to, and the time is also given, let's say. All right. Let's say
Okay.
time is also given. Instead of this particular distance, time is given this time. Okay.
Okay.
So if you need to find the acceleration from these quantities, which of the kinematic equation would you use? You
Well,
get my point. So I use this particular equation because all the other quantities were given: final velocity, initial velocity, and the distance traveled. But instead, if I am given final velocity, initial velocity, and the time taken for the traveling of the bullet to come to a halt, to come to a rest, which of the kinematic equation which I use to find the this acceleration? Can you tell me that?
velocity initial equals velocity final plus acceleration times time.
Exactly, but just the opposite. Velocity final equal to velocity initial plus acceleration times
Okay.
time. So from there, I write it like this: v equal to, v is the final velocity, initial velocity u plus ft. F is the acceleration, t is the time, right?
Mm-hmm.
And in this given scenario, what you know is initial velocity, final velocity, and time, and you can easily find the acceleration, correct?
Yes.
Okay. From there, you'll find the time, and or not time, you know the time, you'll find the acceleration, and you just plug into the equation. Okay. So depending upon which are the quantities that are given, you have to choose the suitable kinematic equation. That is the take-home message from here. All right.
Okay. Yeah. Do you know all three of them? Can
Yes,
you tell
yes,
them?
yes, yes. So
So number one is the velocity
okay,
final
so
speed.
I'll just write it in the following the convention that I use. So
Okay.
v is the final velocity, u is the initial velocity, f is the acceleration, s is the distance traveled, and t is the time. All right.
Okay.
So v equal to u plus ft. All right. So I'm
Yeah.
not trying to derive these equations here. Uh, I'll just write it down.
Yes.
Next would be S equal to ut plus half f multiplied to t squared vs, and then there is the equation that we just used here, v squared equal to u squared plus twice v squared equal to u squared plus twice fs. Yes.
Okay.
Now,
And
you tell me all the this notation. What is v?
v is the final velocity.
U,
Is the initial velocity.
f,
Acceleration.
and what if the particle, the not the particle, the object is slowing down? Okay, so let's
If
say
it's slowing down, then you have to put minus.
why? Because this time f is itself negative. Correct?
Right.
Okay,
Yeah.
so all the equations there, wherever you see f is the acceleration, it will be replaced as minus f. Correct?
Yeah.
Okay.
So what is S?
S is the total distance traveled.
Oh, okay.
Okay, so s is the distance traveled, not distance. Yes, s is the distance traveled in one, and these are all one directional equations. Okay,
Okay.
that means if you let's say move in one particular straight linear direction, then only all these equations are applicable. So you are initially from here, finally you move to here. This is the equation. Okay,
Uh-huh.
but if you are moving in a zigzag way, then you can't simply just use all these equations.
Okay.
So there might be some sophisticated way of doing this, but as long as you are confined in 1D, one direction, you are very good, very safe with all these equations. Okay?
Okay.
Okay, that's all. So please try to write it down, all these equations, before I clean
Yeah,
the book. Okay,
I did. That's why I asked you.
oh, sure. So
Okay, so you want to move on to number three on problem set number three, or what?
before we do that, I think let me just have a look over the third problem set, so that third.
Okay.
No, this one was the third problem set. The Thomas Magnum, right?
Yeah.
And the second problem set is, yeah, second problem set. Yes. So a car accelerates from rest with 4.50 meter per second square. All right. How far will it have gone by the time its speed is 80 kilometer per hour? Yes, this is very good question. I mean, good in terms of explaining the kinematic equations.
Is that on what problem set is that
The,
on?
okay, problem set two. Second
Okay, let
problem set.
me
Sure.
let me open.
Yes.
Okay.
All right. So did you look
So
at the
the
first question? A car accelerates from rest with 4.50 meter per second square. That question. All right.
okay, so the initial velocity is 0.
The initial velocity. Okay. First, tell me what is it? What is needed? What do you have to calculate?
It wants to know distance.
Distance traveled in one direction. So in my notation, I write it as s. Correct. S
Yeah.
is the distance covered. And then to find S, what are the quantities that are given? I have to look at that. So what are the quantities that are given? Uh,
Right.
Acceleration is given, right?
Uh-huh.
And then a curve accelerates from rest. That means initial velocity is also given.
Yes.
So initial velocity is also given, acceleration is given, and final velocity is also given, correct? 80 kilometer per hour.
Yes.
So let's just say if I straightforward use s equal to this formula ut plus half f t squared, that this is a valid equation, is that correct?
That is what?
This is a valid equation, this is a standard equation for finding out the distance
Yes.
traveled, correct?
Yes.
So what are the quantities that I know? I know u, right? Initial velocity is 0.
Yes.
I know acceleration, right? That is
Yes.
given in the first part, but I don't know the time.
No.
So I better not use this particular one because I don't know one quantity in here. Do
Okay.
you understand me? So I wrote this equation just to emphasize that depending upon certain condition, you have to choose another equation. Now, can you tell me what is the next equation that involves this s quantity, this total distance traveled?
Um, that has that is it
Yeah.
velocity final squared
Yes,
equals
v
velocity
squared.
initial
So
squared.
v squared equal to, and we'll see which one is suitable for this particular question. Okay,
Okay. What?
u squared plus twice fs. Right.
Uh-huh.
So now we'll see which one is more useful. So what we know is final velocity is 80 kilometer per hour or something, whatever that is, some number for final velocity. We know that, correct?
Yeah.
We know initially it started from rest. So initially its velocity is 0. We know that, correct?
Yes.
We know that its acceleration is 3 point something or whatever, some number given. Is that correct?
Yes.
So we know all the quantities. We know all the quantities except for what we have to find, and that is the total distance covered. This quantity we don't know, right?
Right.
So which one of these two equations would you use to find the value for total distance? Can you tell me?
Well, this one, but we need to rearrange
This
it.
this one means the let me just number it 1 and 2, and this,
Number two,
yes. Why?
because it gives us the total.
All the informations required to find the total distance, correct?
Yeah.
And the first one is actually lacking one particular thing, that this quantity, the acceleration, right?
Yes.
No, acceleration is known. Acceleration, the time, this time was not known.
Oh yeah, we don't know
You
time.
don't know time. So if we don't know the time, we can't solve this question. Then we have to do a lot of things to find time. We don't even try to look at this. This is not applicable here. What we'll do is we'll use second one. All right.
Yes.
So this is the way I want you to solve all these problems. First, you try to identify what are the quantities given and what is the quantity that you have to find. Then you choose the suitable equation. You will of course write all the three equations first, and then check for yourself which is the most useful one. All right.
Okay.
And when you have solved 10, 20, 30, 50 problems, you'll be able to, just by look at the question, you'll be able to pick the correct equation.
Okay.
Okay, so that's all. So I think you can put in numbers and find the value here, right?
Yes.
So there is
Yeah.
no point in spending time in algebra.
No.
Okay. And then there was how was the second one? Second one says from 6 initial velocity was no, not initial. Our start initial was 0, it then maintained constant speed, okay, and then accelerated uniformly, coming to the rest at a point 58 meter from that at which the brakes were applied. How far has the bus traveled? How long has it traveled, and what was its average speed? Okay, this is very good question. This is a bit tough question, but uh, okay, I want you to read it out.
So
The
I
second question.
think
Okay, oh, please tell me. Please go on.
um so it accelerates for 6 seconds at that, maintains a constant speed for that, and then brakes are applied. Okay, so we know that is distance is 58 meters.
Coming to
So
rest at a point 58 yes.
58 meters, and then the is the acceleration is 3.2 meters per second
No,
squared.
it's not the total distance covered is 58 meter. 58 meter is at some point where the brakes are applied. Is it correct? It then maintains constant speed for 48 seconds and then decelerates uniformly coming to rest. No, no, no. 58 is where it stops. Okay. From that, at which the brakes were applied. At which the brakes means at which point the brakes were applied. Okay. How far? 58 meter from that at which the. Okay, 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 okay. I understand. I understand. I understand. Okay, so can you draw a schematic diagram of this problem first?
You want me to do it?
Yes, not to do it, just to tell me the concept.
Okay, so the bus starts from rest, accelerates for 6 seconds at, what did it say? 3.2 meters per second squared.
Yes. So you,
Three
you, you don't
point.
you don't have to put in all the numbers. You can just put time equal to t1 or t2, acceleration equal to f1, f2. That would matter. That would suffice.
Okay, and then maintains a constant speed for 48 seconds. And then it comes to rest at a point 58 meters. So comes to rest
Okay.
at 58 meters.
No, no, no. That is not 58. This is where the brake is applied, and this is 58.
Okay.
So you apply brake at certain point of time, and from there you travel 58 meter until you stop. All right.
Okay.
So
Yeah.
that was asked. I think that was asked in the question. So then why don't you we try to draw a graph from this one, all right? Because in this particular schematic that you just drawn here, it's not very easy to look at where it accelerates or where it decelerates, whatever that it does, whether it's moving in a constant velocity or not. We don't know that from this particular diagram, right?
Yeah.
So we'll try to draw a graph from here, a graph which will show all the necessary informations. Okay.
Okay.
Okay. So let's see. Let me erase this one for a moment, and so let's say this. Now the thing with graph is whenever you are drawing a graph, you have to specify the two coordinates. Which one is in the x direction, which one is in the y direction, correct?
Yes.
So what I'll do is maybe time. Okay, maybe time. In
Yes.
x direction, I take time, all right, and in y, I take the distance. All right.
Yep.
Y distance. What I could do is, all right. We'll see. So initially, it starts from 0, then it maintains. Okay. So this is something like this. At velocity and time would have been much better. Wait, I'll just. Okay, does something like this explains the problem? If I say this is the instead of x distance, if I take this to be velocity, yeah. I'll explain in a moment, all right?
Okay.
Okay. So what happens is initially the velocity was 0, right?
Yes.
Then it moves with a constant acceleration for, let's say, time t1. Is that correct?
Yes.
And then it reaches certain velocity that is given in the question. Then it retains the constant velocity and moves for some time, right?
Yep.
And we'll assume that to be t2, let's say, and I don't know if that is given or not. Then it decelerates means its velocity is slowing down. It applies brake and it slows down. Is that correct?
Yep. Yep.
And since its velocity goes down, after some time it must come to rest. Is that correct?
Yep.
Okay. So what happens is it covers 58 meter in this particular case, and then you have to match what are the quantities given. Car accelerates from rest, so the time, we know the initial time, the maintain. So what is it that asks how far has the bus traveled? All right.
I
So
think T2 is 48 seconds.
what was 48 seconds? Okay, just there are too many things given in the question. So 58 and constant speed is 40. T2 is 48 seconds. So actually T2 is given. This T2 is 48 second, right?
Yep.
Okay, that's good. So if I now try to look at the first thing that is asked, it is how far has the bus traveled, correct?
Yep.
So if I try to find out how far the bus travels, then what I'll find is S1, that means traveling a total distance traveled for time t1, plus total distance again traveled for time t2, S2, plus total distance traveled for the time t3, which is S3. Is that correct?
Yes.
Because I've segmented the problem in three different segments, three different zones. One is for time t1, one is for time t2, another is for time t3, let's say. All right.
Okay.
And t1 is when the car has acceleration, t2 is when it's moving with a constant velocity, t3 is when it decelerates. Correct?
Yep.
Okay. And corresponding distance traveled is s1, s2, s3. So first we'll try to find s1. Can you tell me which equation would you use to find s1?
Well,
Before that, just try to look at what are the things that are given.
so is velocity final equals velocity initial plus acceleration times time for the first one?
Okay, if you use that, we'll see what happens. Let's say for S1 we'll use velocity final. Velocity final is not known, equal to velocity initial, which was 0, correct? Initially the car starts from rest. Is that correct?
Yeah. Well, I think velocity final for that time segment is known.
Velocity final for the time segment t1, is it known?
Yeah, it
uh,
said that.
okay, just let me have a look. No, it's not known. Try to look
Uh,
at the first line. It says the acceleration is 3.2 meter per second squared, and the time duration is 6 seconds. So t1 is also known. T1 is equal to
so
6 seconds,
uh,
right? So now you yourself be able to tell me which is the equation you should use. I don't think v square should be used, but As you said, I will see what's the problem with that.
So it's the change in distance equals velocity initial times time
Yes,
plus one half.
yes. So ut plus half of t squared. I'll just write the same thing, ut plus, and you tell me why you can use this, plus half f t squared, correct?
Yeah,
And
because we're
so are all the
because we're
quantities known here?
yeah we're trying to find acceleration and we know all of the other parts.
We have
Or
acceleration. You know, acceleration is
trying to
given.
find this.
Look, acceleration is given, time is given, and then initial velocity is given, which is 0, right?
Okay, yeah.
That means these term cancel out. 0 multiplied by t is 0. You have half some known quantity multiplied by some known quantity squared. Is that correct?
Yes.
That gives a distance, total distance covered, correct?
Yep.
Total distance covered for time t1. All right, so for now we know s1, right?
Yes.
Okay. So next, so what I'll do is, in this particular lesson, I'll just go through the concept, and then maybe I'll solve in my notebook, and I'll send you the solution, and then you can cross check with mine. All right?
Um. Okay.
Okay. Because if I try to solve all the numbers over here, it might take some quite long time. Or you can for yourself, you can just put in the numbers in a calculator to find the value of s1. Now what we have is v equal to,
Well, can we write out all of our knowns? Because I feel like we haven't done that yet. We drew the diagram, but we don't have like,
okay, sure.
okay,
So what we have is, so why don't you tell me whatever the quantities that we know. Hello, you there?
yeah, I'm here. It's confusing. I don't know. That's why I'm asking you.
Okay. So firstly, we have three segments in the problem, all right? Three different
Yeah.
zones: first time zone, second time zone, third time zone, correct?
Yes.
So what is happening in the first time zone, can you tell me?
Yeah. So initial velocity is 0.
Yes, and the car is accelerating at this time zone to reach some final velocity. Is that correct?
Yeah.
And in that time, it moves some distance, right?
Yeah.
Okay. So what you know is the initial, I think initial velocity is known, which is 0. Then its acceleration, initial acceleration is known, which is just, I'll write f1, let's say. f1 is, all the 1, 2, 3 are for the three different time zones, okay?
Okay.
Okay, so we know f1, and then we know t1 as well. We know t1 as well, right?
Yeah.
So if we know f and t, and then initial velocity, let's say u1, if we know that, then we can easily find out the total distance traveled using this particular formula, correct?
Yes.
Okay, and that's exactly what we did. So we found the value for s1, okay?
Yes.
All right. Next, what is given? We'll try to find what is given.
So at the second time segment, we know
For
that
the second, yes, what is given?
um let me see.
Yes.
It maintains a constant speed. So we know time is 48 seconds.
Yes. So what we know is t2 this time, right? The subscript it is 2 for this particular time segment. T2 is some number, all right? And what else?
Yes.
What else do you know? Can you tell me?
Um no.
You know that whatever the velocity that the car had initially in the first time segment, in the
Oh yes.
like final velocity, whatever the final velocity from the time segment from t1 is the constant velocity in here, correct?
Yeah.
So u2 is also given, provided you have to find the value of u2 from the first segment. You understand me?
Yeah.
So the number of corresponding to u2 is not given explicitly, but its expression is given. Like once you find u2, that is what you are going to apply here. Correct? That information is given. All right.
Yes.
So our job is to first find the value of u2 using the first time segment. Correct?
Yes.
Okay. So how would you do that? What you do is, so u2 is the final velocity from the first time segment. Correct? You understand me?
Yes.
Which is the initial velocity u plus f f1 this time t1. You tell me if you have any confusion in understanding.
No, I don't.
Initially we
That's
started from 0. We had an acceleration of f1 and we moved for time t1. Correct? To
yes.
reach a velocity u2. All right. So
Yeah.
we can easily find the value of u2 from these two numbers. F1 is also given in the question, t1 is also given in the question. Is that correct for you?
Yeah. What? So. Uh,
Okay, why don't you tell me
mm,
whatever that I told?
well, what? I don't know. I'm confused. My son's awake and I can't focus right now. I'm sorry.
Okay, so what happens
We can
is,
just figure this out later.
all right, the thing is, u2 is something that we have to find out, correct?
Yeah, confusing me is I'm having to stop and think about what U2 is instead of velocity initial. Um, it's
Okay,
just early for me and I'm tired, so I don't.
okay,
I
okay.
think that maybe to make this easier for me of using U, maybe we can use velocity initial. And you don't have to do this now, but just for like,
Okay,
like
okay.
I.
So what I'll do is, I'll write a clear step by step illustration explanation of this particular problem, and I'll send it to you, and then you have a look for yourself and get back to me if you understood everything or not. So then what would happen
Okay.
is, both you and me will have the solution in our hands, and then we'll have a discussion. So there it will be much more easier
Okay.
for you to understand, because there are so many variables in this particular problem. Then you'll be just out of focus, right?
Yes.
Is that what happening to you?
Yeah.
Okay, so I'll just solve